Thank you, Peter. Distinguished participants, colleagues, ladies and gentlemen. It is certainly a great pleasure to me to be contributing to this important meeting of the BGRI. I would like certainly to pay tribute to a great man, Dr. Norman Borlaug, to whom ICARDA is very indebted to. Dr. Norman Borlaug selected the site of ICARDA in Tel Hadia in northern Syria in 1975 with Dr. Bob Havener and Jit Shervestiva. Some of you may know Jit Shervestiva, who was with the Ford Foundation at that time. I had in my office in Aleppo a photo at the hill where the site was selected in 1975. And what's most interesting to tell about the vision of this man, that when we are really unfortunately relocated now because of the unfortunate developments in Syria, we tried to find a site similar to Tel Hadia in North Africa and West Asia, and even in Central Asia. And let me tell you, we could not find for a year a site as good as Tel Hadia. That tells you what a visionary man Dr. Borlaug was since that time. And ICARDA, in commemorating the close relationship with Professor Norman Borlaug, we named the Wheat Training Center after him, but he insisted to say Borlaug-Havener Wheat Training Center rather than only Borlaug Training Center. So this is really, I want to mention to the audience. Jenny, unfortunately, is not here, but I'll mention that to her personally. Now, talking about rust, I'll be talking about striped rust and the Turkey-ICARDA Regional Cereal Rust Research Center in Izmir. And my outline will cover the importance, which I think most of us know, the epidemiological aspects, the elements of a striped rust strategy, Turkey-ICARDA Regional Cereal Rust Research Center at Izmir, a conclusion and acknowledgements. Now, of course, we know that wheat production is very much threatened by several biotic, I would say, stresses as well as abiotic stresses, and certainly rust really stick out as the most important threat. Stripe rust or yellow rust, leaf rust, and stem and black rust are really the most important. And globally, I would say, and economically, the yellow rust is the most important, which is caused by Buccina styriformis. Now, of course, there are several reasons why this problem is very serious. We are still working really with mega varieties with very narrow base of resistance. Some of the major local, I would say, varieties do not have adequate level of resistance, and the climate change is really, with the warmer temperature in winter in some areas, is inducing more sort of new virulent races of yellow rust, which really makes several epidemics to be very serious. Of course, we don't have globally a good assessment of the losses due to yellow rust, but you can see from this slide, there are over years, and this is more recent years, even in the 50s, you know, China was certainly affected, Turkey also, Iran, Uzbekistan, Morocco, Syria, Ethiopia, and Kenya has been always hot spots, really, Ethiopia and Kenya, for all types of rust, particularly the yellow rust and the stem rust. Now, when we look at this map, of course, we do have this problem as a global problem, but certainly the incidence differ from one region to the other. Those that are red on this map, the incidence indicates about 2 to 3 years out of 5 we will have really a epidemic or a certain level of severity with crop losses 5 to 10%, and at the regional level, some of these losses can go up to 25%, as it is the case in 2010 when we had warmer winter in West Asia. And I want to mention also that at the individual crop level, these losses can be up to 80%. Now, the most recent epidemic is 210, was really in severity, was the most serious. I remember in Syria, the yellow rust was not really very serious. In that season, when you walk in the field, you go out with your jeans, they become yellow because of the spores. It was really very, very, very serious infestation, and certainly the farmers were not ready with fungicides for that at that year, and losses were up to, I would say, on an average, probably 40%, which was a great loss. Now, in 2013 also, there has been quite a bit, as you can see from the histogram down there, this has been much, much wider spread than ever before. Now, when we look and compare I would say, the long-term investment to reduce the threat of stripe rust, we see that this is really very, very shy compared to what we are having really in UG99, which is another major, certainly, threat and very serious threat. But we do have a global program, and we should really thank again BGRI and all of those who are contributing to that. And of course, in terms of the clearly defined target, this is very clear. In case of the stem rust, it is now more is needed in the stripe rust. And when it comes to the information system and data management, it is global at the stem rust level, and it is regional, and more is needed at the global level again. And again, pathotype capacity, we really have that in the stem rust with certain limitation. And of course, as you know, the global regional rust center, the global rust center in Denmark is playing a very important role, but certainly with limitation in terms of resources. Now, so we really need to be ahead of the disease, and this is where more investment is needed. Now, with respect to the epidemiological aspects, we need more studies there. Certainly, there are certain factors to consider, conducive environmental conditions and the climate change, the genetic similarity of the mega varieties. As I mentioned, we have lots of monoculture, cereal after cereal, and some of the varieties are really grown on vast areas with very narrow genetic base in terms of sources of resistance. And then, of course, being windborne, therefore, this is a constant threat, irrespective of the borders. We know that rust does not respect borders. And then, of course, we do have overlapping continuous cropping season, as we will see later, and wide spread of the alternate host from, I would say, the east of Africa up till South Asia, which makes it really very serious. This is a good example of the green bridge, where we really have cereals that are susceptible to the stripe rust. And if you look at the different parts of the world, you can see the green is really continuous throughout the year, which means this rust is surviving with us throughout. All you need is more conducive conditions for us to flourish. Now, again, we need more studies on alternate hosts. We don't have good understanding of alternate hosts, which they really exist, as I mentioned, throughout East Africa, as well as West Asia and South Asia. And more is needed there. Now, this is the wind pathway of, I would say, yellow rust. This is in the 80s, how it reached to India. And this tells a lot about the importance of a global strategy to cope with the rust disease. As I mentioned, borders don't mean anything for any rust, and rust does not sleep just to coat the great Norman Borlaug, and therefore we have really to develop not only a regional program, but more of a global program similar to UG99, and I hope we will be able to do that. Now, of course, in 2010, new races emerged simply because of the fact that in West Asia, the temperature in winter was 4 to 5 degrees higher than the normal. And with the, I would say, rain and the supplemental irrigation to break the cycles of drought, the humidity was there and the yellow rust flourished. No effective fungicides were available in large quantities in the countries where the epidemic started, and really farmers suffered tremendously. And as I mentioned, on the average, you can say 40% in West Asian countries of the wheat crop was lost, and with some farmers, because it developed early, because of the higher temperature, some farmers lost 80% of their crop, which is really a tremendous loss. So there has been, again, based on the race analysis that was done, we realized that there is a new aggressive race which is virulent to the widely resistant YR27. And this has been really very serious. Fortunately, that year, we realized that 3 of the varieties that were released, not in Syria, but in the region, were really resistant to this new race. And these were really multiplied through fast tracking in order to be made available to the farmer. But certainly, you need a sort of an emergency strategy in order to cope with rust until you have enough seed available to the farmers. Now, so there is a need for setting a disease surveillance, short to long-term strategy for coping with the yellow rust in wheat. And as I mentioned, the fungicide can certainly play an important role, at least in a certain period until we have enough resistant material available to the farmers. Now, this is the International Wheat Stripe Rust Symposium, which was held in Aleppo in Syria in April 2011. And out of that, elements of a strategy for stripe rust were developed. And we did have, I remember, about 150 participants from 40 countries from all over the world. All of them are interested in this subject, and we really did sort of identify the elements for that strategy. Certainly surveillance and information exchange within and between countries. Basic epidemiological research is very much needed, as well as developing the capacity and the skills in national research and educational institutions, extension service, and at the farmer level in order to adopt a plan to cope with the rust disease. Now, we need also to emphasize more, I would say, looking for a wider range of sources of resistance for rust. And this is extremely important, and this is where the wild relatives should be really playing a very important role there. So we should also approach the stripe rust as a social disease. Stripe rust does not, as I mentioned, respect national borders, and again, rust does not sleep. The rust, including stripe rust, are social disease because the fact requires good neighbors and partners working together and networking in order to make sure that even if you have resistance, your neighbor is also working along the same lines that you are. Otherwise, the sporulation from your neighbor can be very serious to you as well. So it requires building a cooperative attitude for information sharing, the mutual sharing of risk analysis, and the trust at both regional and international levels. We need to develop a national action plan. A multifaceted approach is needed by countries to combat wheat rust, diseases monitoring, and immediate action to combat new rust pathotypes through the use of fungicides. Now, reducing the cropping of susceptible megacultivars across vast wheat-producing areas, we still find the crops that are grown, crop varieties that are grown on 80% of the wheat production area in any one region. And this is extremely serious when it comes to the spread of the disease. We have to reduce the impact of dependence, again, on a narrow range of varieties. We have to diversify cropping of wheat varieties, both in a durum as well as in bred wheat. We need to use non-race specific durable resistant genes, and we need to maintain breeding as a short-term strategy as well, and better understanding of the genetic basis of resistance of those cultivars that are resistant, as well as those that are expected to provide that resistance. We need to search and utilize, again, new sources of resistance using wild relatives and much wider crosses. Now, we need a coordinated effort in seed production. As I mentioned before, even if you have resistant varieties, it does not mean anything if these varieties don't have enough seeds to go to the farmers. So the fast-track seed multiplication is very important. And by the way, I want to commend the contribution of USAID in Ethiopia for their support to seed multiplication of wheat rust-resistant genotypes for both UG99 and yellow rust. And this work has been tremendous help to the Ethiopian farmers. So we really need to replace quickly the existing vulnerable commercial cultivars, and you probably have to target at least, I would say, 10 to 15% a year of replacement so that you can keep up with the problem. Now, so in brief, the elements of this strategy include the following: coordinated pathogen monitoring and awareness, race analysis, which can be done at various levels, trap nurseries, and exchange of information. Coordinated breeding for durable resistance, which would be at the international and national level in terms of utilizing of genetic resources. Capacity development and the training, which is extremely important in terms of both short and long-term training, graduate student, regional traveling workshops involving farmers, meeting with farmers and interacting with farmers to know their perceptions of new lines and the new varieties. And of course, effective seed production system, which is important, particularly if you have a fast-track system for both, I would say, seed release as well as for seed multiplication. Now, let me come to the to the Turkey-ICARDA Regional Cereal Rust Research Center at Izmir in Turkey. And this center is certainly in line with ICARDA new strategy for decentralization. And I would like here to commend the Turkish government for helping in the establishment and contributing dearly to the establishment of this center, and for approving receiving disease samples from the countries of the region, which is really extremely important. Not many countries will accept receiving disease samples from countries of neighboring countries or countries from the region. Of course, we will talk more about this center. As you know, we do have international rust laboratories in the world. The one that was there in Wageningen, the active one now, the Global Rust Center in Denmark, and the Cereal Disease Laboratory, which is with USDA ARS. This is in St. Paul in the University of Minnesota, and the Cereal Research Center in Winnipeg in Canada. These are really international, and of course, there are many national rust laboratories, including Australia, India, Iran, Ethiopia, Kenya, South Africa, Turkey, Pakistan, Egypt, and Morocco. And of course, there has been an attempt in the early, I would say, 2000s to establish a regional stripe rust center in Iran. This center was active for the first 2 years, but unfortunately, due to financial resources, it had to stop. And this is now the new center, Turkey-ICARDA Regional Cereal Rust Center, which is being established now in Izmir, Turkey. I had the opportunity to visit that center with Professor Ronnie Kaufman, and I would like here also to thank Professor Borlaug, the Director General of the General Directorate of Agriculture Research of the Ministry of Agriculture of Turkey, who is with us here, for all the support they are giving. The major goal of this center is to develop and promote durable stripe rust resistance in Central, West Asia, and North Africa through partnership and networking. And I would like to emphasize partnership and networking because we don't want to reinvent the wheel here. This center will be addressing the Central, West Asia, and North Africa region, which is really a region with 50 million hectares of wheat. And as you can see, Izmir is really central there, and the population of that region is over 1 billion people. And when we look at the importance of wheat in that region, it provides 37% of the total food supply in calories in the Middle East and North Africa. And if we look at the average annual per capita consumption in North Africa, for example, it is 174 kilograms per person per year. In the Middle East as a whole, 158 kilograms, and the total average for the region, 166 kilograms per person per year. And this tells you how important is wheat for that part of the world. And the world average in terms of per capita consumption is only 66 kilograms per person per year. And so the region imports almost half of its wheat needs. This slide tells you clearly that countries like Egypt imports more than 10 million tons of wheat a year. Algeria imports 5. Other, of course, countries are in the same boat. Now, what are the major activities of that center? We have regional race analysis for yellow rust, leaf rust, and the stem rust. I want to mention the beauty of Izmir location, that the conditions are very, very conducive to all these 3 rusts. And at the same time, I would say the rust populations in both leaf and stem rust in Turkey are very much similar to what really exists in the region. And the other component of that, regional field screening for resistance. And then, of course, there will be trap nurseries, which are distributed all over the world. And then training and capacity building, short, long-term, and fellowship training. The center will be interacting with the national rust labs of the different countries. As you can see from this, we will be interacting with all the national rust labs in the region, and of course with the global ones as well, because this is a partnership, I would say, work that should be done together, since, as I mentioned, the stripe rust is certainly a global problem, and a problem that threats food security, considering the importance of wheat globally. Now, this is the trap nurseries that were distributed from Tal Hadia in ICARDA, and now they will be distributed from Izmir. They are really distributed in 210. They were distributed to 80 locations all over the world with 32 countries. And I think this coming season, they will be distributed from Izmir. Now, the progress in establishing the center, of course, the whole engineering designs are already approved, including a biocontainment facility and a pathology building, which is already there. The approval and the allocation of construction funds by the Ministry of Food and Agriculture and Livestock of Turkey were already allocated. ICARDA is contributing $150,000 to that. the construction process has started, and it is expected that the facilities will be fully operational early in 2014. Now, the field screening started this year, as we will see. ICARDA is posting a senior serial pathologist and technicians are relocated now or posted in Izmir. We are having 4 research scientists, MS, they were already hired. 1 postdoctorate will certainly start in March 2011. I would like to thank the Durable Rust Resistance wheat and BGRI really for supporting that, and this was really agreed during the visit when Ronnie visited the center together. Then the field machinery for planting, harvesting are already available, and we do have walk-in chambers that are very important for our work. Of course, we do have a vast field area, which is really needed for the screening. And as I mentioned, the beauty of that site, the humidity is very conducive to all types of rust that we have in the region. Now, this is what was done really, the activities this year in 2013, 10,000 genotypes from ICARDA and the, I would say, Turkey, CIMMYT, ICARDA wheat program, the winter wheat program in Turkey, germplasm, as well as national breeding material were evaluated against local race of yellow rust. Oh, thank you. Yeah, okay. And then seed multiplication of the 3 international trap nurseries, the one for yellow rust, the one for stem rust, and the one for leaf rust. And the 3 trap nurseries, as I mentioned, will be distributed from there. These are some of the slides within the pathology and within the field labs. There is, fortunately, we have a training center and a convention center in Izmir, which is really very close. It is really the agriculture training center, agriculture research and training center next to it, which is very important. And as I mentioned, we will talk about race analysis, field screening, MS and PhD, and this work will be done in collaboration with BGRI, FAO, ICARDA, and the national and international, I would say, labs. These are some of the slides. And let me here acknowledge the contribution of the Ministry of Agriculture of Turkey, the General Directorate of Agriculture Research and Policy of Turkey, the Asian Agriculture Research Institute in Izmir, and the Central Research Institute for Field Crops in Ankara, and certainly the Borlaug Global Rust Initiative for their contribution and support to the center. In conclusion, the only way we can cope with the continuous threat of stripe and yellow rust is to ensure durable resistance through effective partnership and networking. And partnership and cooperation is needed across countries, across institutions, across disciplines, involving wheat pathologists, breeders, biotechnologists, agronomists, and seed multiplication experts, across the research for development continuum, involving the researcher, extension agent, seed producer, and most important, the farmers. And we should always remember that rust never sleeps. And certainly this is a great statement that tells lots and lots about wheat rust, and this is where the vision is. And therefore we have to continue working on that. I have to end by saying that the diverse impacts of climate change on the durability of stripe rust disease resistance need to be considered at national, regional, and international research and development levels. Climate change is certainly a major threat for all of us in many ways. And let me end by announcing the second International Wheat Stripe Rust Symposium, which will be really held in Turkey in May 2014. Pretty soon we will be doing the first announcement. I would say it will be probably around the 10th of May, but we will fix the date and come to you on that. And let me thank you very much for your attention. Thank you.